Recording. Okay, we started and I forgot to record. I'll zoom in on this part, but if you missed it, it's pretty self-explanatory. Or I'll post last year's video, you can watch that. This part,
Yeah, technically it's like.
I already talked about. So make sure you copy that. Very self-explanatory.
Well, what if you do?
Well, technically, we don't-
All right, guys, we'll talk about coin tosses in a second. Let me get through this. Now I'm on number one. This is so interesting, but we gotta get into probability, okay? This number one probability, we're talking about Maggie and Elizabeth, and they each have a bag of M&Ms, okay? Each girl has counted her M&Ms and has discovered the following proportions of the candy in her bag, okay? So Maggie has 0.3 of her M&Ms are green, 0.2 are yellow, 0.2 are red, 0.2 are brown, and 0.1 is blue. How much of that is that all together? What do all those add up to? One, which is 100%. So you can think of these as all percentages. 30%, 20%, 10%, all that stuff, okay? So instead of saying that of 12, I have 2 that are a certain color, I instead said 30% or 10%, okay? So we've already done the successes over total, so we don't need to do that. We're just gonna take the decimals given to us, okay? Same thing with Elizabeth. Her proportions are a little bit different, but they also add to 1 or 100%, okay? So it says, if a candy is chosen from Elizabeth's bag, what's the probability it will be green? What's her percentage of green M&Ms?
0.2.
0.2. So her probability is 0.2 or 20%.
Wow.
All right, a candy is chosen from Maggie's bag. What's the probability it will not be yellow? How'd you get that?
Because it's number 3 minus the yellows.
Wow.
1 minus the yellows.
There's no way.
Or you could add all these other ones up, but what Avery did was easier and faster. So she goes, I want not the yellow, so 100 minus 20 is going to be 0.8 or 80%. All right, now we're choosing a candy from each bag. What's the probability they'll both be red? So when I go to Maggie's bag, I want a red. What would my probability of that be?
20.
Good, 0.2, 20%. And at the same time, in the same situation, in the same scenario, I also want a red from Elizabeth, so I'm going to multiply these two numbers. What's my red from Elizabeth going to be? 0.3. So 0.2 times 0.3, it's 0.06.
Oh yeah, it gets smaller.
It gets smaller. We want it to be 60, but it's only a 6% chance.
Wow.
Ooh, that's a small percent chance. Yeah.
Good.
All right, what's the probability if a candy is chosen from each bag that neither will be brown? How many are not brown in Maggie's bag? 0.2 are brown, so how many are not? 0.8, good. 1 minus 0.2. And at the same time, so multiply, we want the probability it's not brown. 0.9, so 1 minus 0.1 is 0.9. So we get to multiply 0.8 times 0.9.
72%.
0.72. 72%. Okay. Now this next one, order matters. It says if a candy is chosen from each bag, we're going to go Maggie and then Elizabeth. What's the probability that the first one will be green and the second one will be blue? So the green one will come from whose bag? Maggie. So what's the probability we'll get a green one from Maggie? 0.3. And then we have to do Elizabeth next. What's the probability we get a blue one from Elizabeth? 0.2. We just did that math a second ago, didn't we?
0.06.
0.06 or 6%.
Why'd you say order just matter? Well,
Order matters here
doesn't
because
order not matter in multiplication then?
it doesn't matter in multiplication, but it matters which one I pick. Let's do the next one, okay? Because this one says, if a candy is chosen from each bag, we're still going from Maggie to Elizabeth, but this time we just want one of them to be blue and one of them to be green. So it doesn't matter if the first one's blue or the second one's blue, but we need one to be blue and one to be green. So we're going to do both situations, okay? We're going to say, okay, we're going Maggie first. So we're going to say Maggie's got to be the blue one, and then Elizabeth has to be the green one. But we also could have drawn from the blue from Elizabeth second, and then that would have meant that Maggie would have had the green. It doesn't matter which one you pick, which order, whether you do blue first or green first, as long as you get one from one bag and one from the other. And if we get a blue from Maggie, then we have to get a green from Elizabeth. So that's one scenario we're okay with. And if we get a green from Maggie, we need a blue from Elizabeth. So that's another scenario. So we will end up adding those scenarios together.
Wow.
So what's the probability we'll get a blue from Maggie? Good. What's the probability we get a green from Elizabeth? Good, and that's a multiplication because that's still one time. I need an M&M from both, so I'm gonna multiply those together. That's one scenario, and then I'm gonna add that to my other scenario, which is good, which we just did a second ago, right? That's how they're a little bit different. So I get 0.02 plus 0.06, so 0.08 equals 8%. You think it maybe would be a bigger percentage because we can go from either, but we still just don't have a lot of blue or a lot of green. Okay. All right, if a candy is chosen from each bag, what's the probability that neither will be red? How many are not red in Maggie's bag? 80%. What's how many are not red in Elizabeth's? Good. 80 times 70 or 0.8 times 0.7 is going to be 0.56 or 56%. All right, we doing okay with that?
Are
Alright.
there the tests or quiz whenever can be like word problems like this?
The quiz will not have word problems like this. The quiz will have problems that I'm about to do. This could be on the test. I haven't looked at the test recently. I did look at the quiz. So the last thing we're doing today, this is on the quiz. So what Carson just asked, what we just did is not on the quiz. What we're doing right now is on the quiz. And this stuff is also easy. We're talking about cards. We're doing hands of cards. We're basically playing like a poker game or like a game of Go Fish, and we're dealing 5 card hands. Okay? Before we do this, we've got to have a basic understanding of cards, which I found out every year that some of us don't really know that much about cards. I don't mean that to hate on you. I just now need to teach you some things about cards. So very basic. How many cards are there total in a normal card deck? 52. Don't laugh.
So good.
This is why we're doing this, is because I, for the longest time, thought you guys all knew it was 52, and I'm finding out not everyone does, which is okay.
How many letters was out there?
All right. What is another way that cards are differentiated?
Their suit.
They're suits. How many suits are there?
Four.
4 suits. What are they?
Spades, clubs, hearts, diamonds.
Spades,
What?
clubs,
Hearts, diamonds.
hearts. That's my poor example. I did much better with my club earlier today. Hearts, diamonds. Ooh, this is a fun one. Now we have 4 suits. How many different colors do we have?
Gold. 2.
2 colors.
Sure.
Red and black.
All red.
What's another differentiation we have between cards?
Above 10.
Numbers. So I've got, let's call them types. Between numbers and face cards, how many different types of cards do we have? 13. Because there's 10 there's 2 through 10, and then an ace, so I think that's like 1, that's 10, and then there's a jack, king, queen. So there's 13 types of cards. How many number cards are there? 10 number cards. Do we count ace as a number card?
Yeah.
Sure. Well, I don't think it has a face on it.
Yeah.
So I'm gonna count face cards. How many face cards do I have?
4.
So we're saying 10, count ace is 1.
We're gonna count ace as 1. We'll say 10 different numbers. How many different face cards do we have?
4.
I think only 3.
We're not counting jacks.
We are counting jacks, not counting jokers. How many total face cards are there?
4, 12.
That was a
Go Fish.
I've never used.
12.
I just throw them away.
Because there's 4 different suits, and there's 3 faces. Each face has
Counting aces or face is
Yes.
each of you.
So please don't use ace because it doesn't have a face on it. So once you think of face cards, ones that have faces on them. If there are 10 different numbered cards or 10 different, we can even call those maybe not numbers. Let's call them non-face cards.
So
How many total non-face cards are there?
40.
40 total non-face cards. If I have 13 different types of cards, how many of each type are there? How many queens? How many aces? How many twos? Good. 4 of each. How many, if there are 2 different colors, how many total black and red cards do we have? 26 of each. And if I have 4 different suits, how many diamonds are there? How many hearts are there? 13 of each.
Yeah, remember all that, places.
I would not say you have to memorize all this, but you have to like know these things. So if you like, I probably don't have memorized in my head 13 of each suit, but I can easily do 52 divided by 4, right? I maybe don't have 26 memorized in my head,
Let me think.
but I do know 52 divided by 2 is 26. Does that make sense?
Yeah.
No, it's literally on your notes. Guys, write it down.
I didn't wanna write.
Bless you.
Oh, I don't want to write it all down, but do I have to memorize it? God, you guys are so irritating.
10 is the answer
What?
for A, I think.
I don't think so. There's a lot more than 10. Okay, so let's think about cards. If we're playing card games and I'm dealing, how many cards do I have in my hand?
52.
52. I'm dealing. I have 52. And how many do you want in your hand? 5. So we have a total of 52 cards and you only want 5 of them. So we're going to say 52, choose 5. 52 C5.
This is NCR.
This is NCR. Why is it not NPR?
Because
It's not probability.
it has to get smaller.
Because
It does get smaller. That's why we're doing one of them.
permutative.
Was that what it was?
25.
That's what P means. Why is it not P?
Because some people can have the same
Because there's
number.
not a front and back.
No.
No.
That no,
What was the big thing about
have the
P's?
same card. Nobody can have the same card.
No one can have the same card. That's why we have to get smaller. What was the difference with P's and C's?
Prizes.
Order, does
Permutation.
it matter?
Order.
When you are dealt cards, does it matter if you get your ace first or if you get your ace last? No, because then you get it in your hand. When you guys pick up your hands, do you immediately shuffle it around and get things where you want them to be? All your reds together, all your hearts together. You shuffle them up immediately. It doesn't matter if you got the 2 first or the 2 last. At least you have a 2. So order does not matter. When we do this card stuff, it's always going to be NCR. Order doesn't matter. It's all NCR. Okay. And if we were to put that in our calculator, which we're going to do just super quickly so we can do a couple more problems, 52C5 is a huge number.
Yeah, it's 2 mils.
Yeah, 2 mil. Oh, come on.
It's
Whatever.
up 2,598,960. I don't know how you say that.
That's a huge number, right? That's a lot of different hands you could get. Okay. Now, because we're doing probability, we're going to go number of successes over number of total. This total we just found, we are going to use this for all of the rest of the problems. All of them are going to be 52C5 on the bottom. Okay.
And that's, you use that when it's probability, right?
When it's probability. See how they all say, what's the probability? What's the probability? What's the probability? So all of them are going to be over 52C5. So if I look at letter B, it says, what's the probability of being dealt a hand with all diamonds? Okay. How many diamonds are there?
4. 13.
13. How many do I want?
5.
5. 13C5. We know that there are 4 suits and there are 13 of each suit. So 13C5. What's the probability of being dealt a hand with all face cards? Well, how many total face cards are there in the deck? 12. There's 3 different face cards, Jack, King, Queen, but how many total face cards are there? 12. And how many do I want? All of them.
Oh,
I want 5. I only get 5 cards in my hand though. I can't get all 12 of them. I have to stop at 5. So I want 12C5 over 52C5.
So we're not like solving it out.
I don't want you to put that in the calculator. I actually like this as an answer because I then get to see your brain work. When you give me weird decimal numbers, I don't really see what your thought process is. And I also need this to be written somewhere so I can give you full credit. So I actually like answers like this. Let's do another one. What's the probability of being dealt an all red hand?
26.
26C5 over, over,
52C5.
good, over 52C5. All right, letter E. What's the probability of being dealt a hand with 3 jacks and 2 kings? Okay, how many jacks are there?
4.
4. How many do we want?
3.
Good, 4C3. Now, I don't just get 3 cards and I'm done. I also need 2 more cards, so we're going to multiply that together. This is all in one hand. How many kings are there?
2.
Oh, I want
No,
2.
4.
4C2.
So you like-
Now I know that I have 5 cards, so I can be done. I want these 2 numbers to both be 5. So I have 5 cards. I can't get any more. So now that's over 52C5.
4C2, is that just 50%?
Oh, we can put it in the calculator.
Yeah, it's not even close.
It's like a number. It's not, so it's not going to be a percent. These are how many ways that you can get that. So if I have 4 things and I get 2 of them, how many different ways can I get that?
I'm gonna pull that out. And
All right, we're gonna pause here. You have no homework because we didn't finish. Cards is on your quiz. So if you need to memorize those things, you need to start now.
Probably right now.
Write it down.